right, so we talked about the 68, 95, 99.7 rule. And that was really handy, okay? And we basically brought in this rule whenever we had data that was symmetric and what? Unimodal, right. So if your data is symmetric and unimodal, by basically looking at it, okay, then you can apply this 68, 95, 99.7 rule. But this kind of has an end very quickly, right? Because it's like, well, I want to know more than just 68%. I want to know maybe specific things about one person, right? Maybe where I lie, okay, or something like that. So the first rules with working with these models is whenever I give you something, for instance, I say, okay, we have some data, the mean was blah, the variance was blah, or the standard deviation was whatever, and I want you to find such and such. The first thing and everything you should do first is draw a picture, okay? Draw a picture, draw the distribution, where the mean's at, maybe what data point you're looking at, and draw, again, what we're doing. We're going to go through this today so you get a better understanding of what I mean by that, but we need to draw a picture. That's going to be very important. So again, we're checking for things that are nearly normal. So if it's nearly normal, again, we're eyeballing it, then it's going to be good enough for us. All right, so if we want to find normal percentiles by hand, we can do a couple of things. The first thing we need to know is we need to know the mean of our data, and we need to know the standard deviation. Because what we're going to need to calculate is our z-score. So let's say we have some data where the mean is 25. Maybe we're dealing with ages, some standard deviation that maybe is like 3.27. Okay, and I have some guy, maybe a guy named Fred. His age is 22. And what we want to know is we want to know his percentile. Okay? We want to know what percentage of people have an age less than 22, given the mean and the standard deviation. Okay? Because the standard deviation and the mean tell us pretty much, and what are we assuming if we're going to be using these normal models? That it's unimodal and symmetric. So this is unimodal and symmetric, or US. I'm just going to write unimodal and symmetric. It's unimodal and symmetric. We have a mean and a standard deviation, so we can tell a lot about the distribution. We can tell a lot about Fred based on his age. So I'm going to calculate Fred's z-score. So how do I do that? I take his age, or the value, minus the mean, and divide it by 3.27. That's negative 3 all over 3.27. Go over here to my calculator. 3 divided by 3.27 equals negative 0.917. And I just forgot my negative up there, so I just slapped it on. So that's my z-score. Negative 0.917. Do you have a question? No. Okay. So now what we have is a z-score, but what we want to know is what percentage of people lie below him. So the cool thing is, so what's the first thing I forgot to do that I just talked about? Draw it. Already committed the cardinal sin, not drawing. Mean is 25. This thing is unimodal and symmetric, right? And Fred, he lies, his age is what? 22. So he's lying somewhere around here. And we're interested in what percentage of people are lower than 22. Well, tell me something. What is the area under this curve equal to? What is the area below 25? 50%. What's the area above 25? Okay, does that represent all the area? So what do both of them add together to give you? 100%. Or 1, right? 100% if we convert it to a percentage, but really it's 1 because we're going to get things in terms of decimals. So the area of this guy is 1. So what we're interested in is what percentage of people lie below 22%, or that area. What's the area below 22? So the cool thing is unless you knew calculus, if you knew calculus, we could integrate this curve from negative infinity up till 22. If we knew the function that represented the curve, and that would be all fun and dandy, and we'd be great, but we don't know calculus, at least we're not assuming that we know it. And so what we have to do is the nice guys who know calculus made us a nice little table in the back of our book to figure out what the percentage is. So everyone pull out your book. It's on A59, the appendix D, table Z, A57, or A58. Actually, we're going to deal with A57 right now. Okay, so basically in that far right-hand column, again, I don't have it on the board, I'm sorry. Far right-hand column, we're dealing with all of our z-scores, right? Everyone see it? Negative 3.9, negative 3.8 z-score, so forth and so on. So why do we have this table? What? I'm sorry, what? A57, A57. It's in the back of the book, A57.
A58 is the one that has a negative. Yeah.
Okay, it's either A57 or 58. Find out where the negative 0.9 section is and go there. So why can we have a table? Because we converted everything into these z-scores, right? And what do z-scores follow? What distribution? A what? Z-scores follow... Somebody tell me. What do they follow? What type of distribution? Normal, okay, but it's something normal distribution. Something normal distribution. Standard normal. So if I had some data and I found out its mean, and then I found its z-score, what would it be? What would the z-score of some data's mean be? Nope. 0. So a mean of 0, and if we found a data point that was 1 standard deviation away, if we converted it to a z-score, what would it be? Plus or minus 1, or 1, if we're talking about above. So this is standard normal, or a mean of 0 and with 1. So this table is telling us, okay, when you convert it to a z-score, we can go to the back here, find that z-score, because we've converted it into this standard normal distribution, and now we can find out what our values are. Okay, so we're dealing with negative 9.17. So I'm going to go down and I'm going to find negative 0.9. All right, now so when you find that, then if you're wondering the row that you're in, so you can see the first column is for the negative 0.90, then it's negative 9.01, or 9.01, negative 9.1, and then negative 9.2, and so forth and so on. So what do we have? Negative 9.91, but it's 9.17, so maybe we want to round. So this is approximately negative 0.92. So I'm down at negative 9.2. I'm going to go over to that third column. And what is that decimal?
0.1788.
All right, so the percentile of this, given our z-score, is 0.1788, or 17.88%. So 17.88% of people lie below Fred's age of 22. That's what that told us. Now you might be like, wow, okay, I have to look up a table every time. This is the 21st century. Can I use my calculator? Of course. I'm going to show you how to do that. So now pull out your calculator. We found out how to use our table. Now I want to do my calculator. So I'm going to do second vars. This vars key. Vars. That's going to pull up this list of things, and I'm going to go down and I'm going to hit enter on normal CDF. Okay?
Where'd you go first?
Second vars. Vars is right here. Right below your down arrow. Second vars. Second vars. Then you're going to hit enter on normal CDF. And the normal CDF function, if we know what our z-score is, all we have to do is say, okay, and the normal CDF function is going to tell me what is the area between 2 points. Well, I'm wanting to just know the area below 1 point. Well, somebody give me a point that's so far that it's like the end. Negative infinity or negative 999,999, okay? So negative 99999. 999, as many nines as you want. Okay? So we're starting there. We want to know all the percentage all the way up to what point? 0.917. That's our z-score. Oh. Negative 0.917. Okay, this is the first thing we're doing. We're just going to do z-score now. Okay, so we know the z-score. This normal CDF, typically what you'd have to do is you'd have to write in, type in the mean and then the standard deviation of your value. Well, we know what the mean and the standard deviation of the standard normal distribution is, or of the z distribution, right? That's what we converted to with z-scores. So the mean is 0 and standard deviation is 1. Now we're just going to hit enter in the parentheses and hit enter. We're going to get 0.17. What did I get before? 0.1788. Well, you're like, well, it's not the same, and that's because we had a more accurate. Now that we have this table can only be so accurate. With this calculator, we can get to fine detail. So this normal CDF, negative 9999, whatever, to negative 0.917, comma 0, comma 1. Now, typically, if you know this, the z-score, you don't have to put in 0 or 1. You can just end after negative 0.917, and then it'll give you the same thing. Yeah.
What if when I put that in, it says here?
Probably because you put a negative in front of the nines instead of this thing right here. This is when you have a negative number, you want to use this, and when you're subtracting, you want to use that. That's probably it. You did it? I don't know.
Did you use the CDF or
Normal CDF, 0.99999, comma. Okay. So try that out and then let me know if you get it, okay? So this is how we do it with z-scores. Maybe we don't know our z-score. Maybe we don't feel like calculating it. So we're just going to tell our calculator what the mean is and the standard deviation is and just give it regular values. So I'm going to go ahead and I'm going to bring up, again, that normal CDF. I'm going to start at, okay, what am I dealing with? What type of variable? It's a quantitative variable, and I'm dealing with what age. So what's the lowest age you can get? Okay. Then, what is the age that I'm trying to go to? Trying to find between 0 and 22. Then I do my mean. Did you get it now? Good. 25 is our mean. And what's our standard deviation? 3.27. I enter all that. Bada bing, bada boom. Get the same thing.